This is the brief on solving trigonometry, exercise 13. Imagine standing on top of a 75-meter lighthouse, looking down at two ships lined up perfectly in the water, because we're going to use basic trig to find the exact distance between those two ships. First, let's visualize the problem. You've got a 75-meter vertical line for the lighthouse, and your line of sight is like a laser pointing down at 30 and 45 degrees. Well, thanks to the alternate interior angles rule, the angles of depression looking down perfectly equal the angles of elevation looking up from the ships. So the closer ship has a 45-degree angle, and the further one kind of sits at a 30-degree angle. Second, now that the triangles are drawn, we solve the inner one first. We use the tangent ratio, opposite over adjacent, because we know the height and really need the ground distance. Since the tangent of 45 degrees equals exactly 1, the distance to the closer ship is exactly equal to the lighthouse height, 75 meters. So what does this mean for the ship further out in the water? Finally, building on that first triangle, we now solve the bigger triangle to find the total distance. For the second ship, we use the tangent of 30 degrees, which is 1 over the square root of 3. This makes the total distance from the lighthouse to the second ship 75 times the square root of 3. To find the final distance between the two ships, simply subtract the closer ship's distance. The crisp final answer is 75 times the quantity of the square root of 3 minus 1 meters. It's absolutely amazing how simply drawing the right triangles makes complex real-world distances so easy to solve.